to the full episode of Classical Mechanics. Now, warning, most of this video is only loosely connected to classical mechanics, but it will be a great introduction for those of you in the know about electromagnetism. So, it's worth it. Alright, so this is that sequel video that I alluded to in the last video about forces. Now, what was that other day? Ah, yes, the quiz question. Here's the answer. Now, my magic cube has a density of 900 kilograms per meter cube, and it will float in water. Alright, so that's our quiz question covered. We can go back to the real stuff. Alright, first let's talk about magnetism. This is a magnet. There are many types of magnets, and this is one called a horseshoe magnet. Alright, so all magnets have a north pole and a south pole. This side of the magnet with an N as a north pole, the other side with an S is the south pole. What makes magnets special is that they attract any piece of iron, nickel, or cobalt. This is what happens when you put those stickers on your fridge. Your fridge is made out of iron. Those stickers actually have magnets in them. So the stickers are attracted to the fridge. Now, what's also interesting about magnets is that they can attract and repel. This is a broken part of a horseshoe magnet I have. Now, when you put two south poles of a magnet together, they really don't want to touch each other. So scientists say they repel. When you put two north poles of a magnet close to each other, they also repel. When you put a north pole close to a south pole, they stick together perfectly, which is called attraction. Now that's it for the basics of magnetism. Now we are gonna see a basic experiment on how magnets can be used in day-to-day lives by making a simple compass. Okay, so now we're gonna see a practical use of magnets by building a magnetic compass. Okay, right now there's a big giant magnet right under your feet. In fact, it's one of the biggest magnets on the planet itself. Now seriously, the Earth is one gigantic magnet with its north pole at close to the south pole and its south pole close to the north pole. Now, that happens because of some complicated geography reasons which I don't have enough time to explain, but anyways, carry on. So basically, what that means is that the south pole of a magnet is attracted to the north pole of the Earth magnet, which is close to the south pole, and vice versa. So magnets want to be oriented in the north-south direction. Now I'm going to show you this by building a magnetic compass. Alright, so in this plate here, I have an elongated bar magnet. The end with the red strip is the south pole, and the other end is the north pole. I'm going to place the plate in the water and then spin it. So what we should see is that the south pole goes in the south direction, which happens to be this way. The north pole is in the north direction, which happens to be this way. So let's just check that this works. electricity. What is electricity? You may have heard it's what makes things like these go. And you may also heard that without electricity, our lives would be very different than what they are. But what exactly is electricity? I'll explain. All around us, there are tiny, tiny things called electrons. They're so tiny you can't see them with your eye, but they're literally everywhere. Now, when a group of electrons start marching in a straight line, we call that march electricity. The direction opposite to the electron march is called the current. When the electrons start the march, it's the same place as where they end the march. In other words, they keep looping around. That's what we call a circuit. For the moment, we're only interested in the current and not the electrons marching. But they play very important roles too, which we'll discuss some other time. Okay, so parts with a lot of electrons are called negative or cathode. Parts with very little electron are called positive or anode. Okay, so now that we've covered that, I can show you what this thing is. Alright, so way at the back, there's batteries. Batteries make electric current. We'll discuss on how batteries work another time, but just be fine by knowing that they make electric current. Alright, so that current starts here at this place marked 17, and then it goes to a wire. Wires are made out of copper. Copper is a good electrical conductor, meaning that allows electricity to pass through it. Another good electric conductor is iron, and a really bad electric conductor is this towel. It's really bad at conducting electricity. Okay, now the electrons march through the wire and end up here at a switch. Switches don't have to appear in the circuit, but they usually do. A switch is like a traffic guard for electrons. When the switch is closed, it's like, okay, you can pass through here. But when the switch is open, no, you can't pass through here. Alright, so now that we've covered the switch, let's go on to the load. The load is this yellow light here. The load is basically whatever happens when you flick the switch. The load can be literally anything. To demonstrate this, I can change a few wires, and we've got okay, that was irritating. And then the electricity from the sound maker comes all the way back to the battery. Alright, so that's simply circuits. I'll make another video another time, but for now, here's a quiz question. The quiz question is simple. What is a conductor?